All right, so we're going to run through the Lentic checklist. This usually goes a little quicker because now that we've kind of spent a lot of time going through the details of LODIC, where it overlaps, we can kind of skip ahead or go a little faster. We just kind of highlight the parts that are a little different. So again, three-legged stool, even with lentic sites, it's still vegetation, soil, landform, and water. We've got similar setup here where it's a number of items and they are yes or no questions. Some of them are potentially NA. And Sherm, remind me, if it's got the arrow in here, does that mean NA is not an option?
No, that means that there's something different about the question.
Oh, that's what it is. Okay.
And LODIC.
Okay, that's what it is. So these green arrows indicate that because we're in the lentic system, it's asking a slightly different question. So the idea of shorelines versus stream banks or overland flow versus, high stream flows. So they are broken out again into the hydrology, the vegetation, and then the soils. So we're going to go through these first ones here, which are related to hydrology. So question number 1, riparian-wetland area is saturated at or near the surface or inundated in relatively frequent events. So this is getting at, do we have the water when we need it for as long as we need it to maintain the conditions that we would expect to see for that site? If you go out there and your shoes are getting wet, that's an easy one to answer. If you go out there and they're not, well, then you might need to start digging down into soil. We saw this photo earlier with some soil characteristics indicating the part of the soil column that's been continually inundated versus the part of it that has a little bit of variation through there. So again, having a soil scientist or someone with soil expertise is good for the ID team. Question number 2, fluctuation of the water table is not excessive. So this is kind of a weird one depending on where you are, especially if you're just used to looking at springs when you do your lentic sites. But in this example here, we've got a large reservoir, and you can see that bathtub ring around the edge. And if you've got too much movement of water up and down, you're not going to be able to maintain the type of vegetation that can deal with one side of the water or the other, because sometimes you're going to be flooding out the drier species, and sometimes you're going to be drying out the wetter species, so you kind of end up with that lack of vegetation. And again, all things being interrelated, if you lose that vegetation, then you lose some of the protection of the shoreline in the case of this photo. In the case of springs or meadows, if the meadow was sort of developed in place over time with a very constant or steady water table level, and then you've caused that to drop for some reason, either through pumping or if you've had some incision that caused the water table locally to change, then you've had that drop and you may give this as a no for that type of example. Or if water is being diverted from a spring and that water is no longer available to provide the water. So between question 1 and question 2, you're going to capture that. Question number 3, or item number 3, riparian wetland area is enlarging or has reached potential extent. Again, how do you know what that potential extent is or was historically? Taking a look at those soils is one way to do it. Looking at the extent of stressed or skeletons of vegetation that you know would have been there with vegetation or with moisture, sorry, is one way to tell. Again, this question is set up so that if it's expanding but hasn't yet reached its potential extent, you can answer a yes. Or if it has reached its potential extent, you can answer a yes, and you just want to make sure to circle which one that is, whether it's enlarging or has reached. So here's an example where the answer would be no. So we've got excavation and erosion and compaction probably, and we've had a drying out of the site, and you can see those kind of darker soils right next to the riparian area there that were probably developed as part of the riparian area, which now are dry and lacking vegetation. So our riparian habitat has narrowed in due to improper use of that site. So here's a site where we've actually gotten to potential extent through recovery. You can see the skeleton of the tree there showing that at some point the site had dried and allowed that tree to move in, but as the moisture recovered and moved the riparian vegetation back out and the soil moisture back out, that tree was then basically drowned out. Number 4, upland watershed is not contributing to riparian wetland degradation. Very similar to the item in the LODIC checklist. Again, if you don't see any degradation in your site, no matter what your uplands look like, you're going to answer this as a yes. If you answer it as a no, you need to be able to point to the degradation in your site and directly tie it to something that's happening in the uplands. And again, because this is the old wording, it does say upland watershed, not upland or upstream. And it's a little bit of a different issue with the lentic sites to begin with, but just remember that it says upland. So here's an example of changing water supply based on the changing vegetation in the uplands. So if you had a wet meadow down in the middle of this valley here, and between 1923 and 1926, the uplands, the density of the conifers in the uplands increased like it's shown in this photo, and they start to use more water. Less of that water gets down to support the site that you're assessing. That's an example where you might say that the uplands, no, the uplands are causing degradation at my site if you've seen that site shrink. Number 5, water quality is sufficient to support riparian wetland plants. Remember, water quality was not something that we included in the LODIC checklist, but we do include it here because of the nature of groundwater-dependent ecosystems, that the water that's coming up may be a particular water quality due to geothermal activity or just by how long the water has been in contact with parent material underground, and if the plants have become adapted to at that site to deal with a certain water quality, if something changes that, that's an issue. Another example here is where we had a little bit of a depression there, a little bit of a area where wetland vegetation could dominate, and what happened was this was dry land irrigation. Groundwater was being pumped from deep, spread onto areas that were irrigated and then harvested for agricultural products. But as that water that was used for irrigation percolated in and then kind of came back up through sort of shallow subsurface flow, there was too much salinity in the water that was being used for irrigation. As it concentrated in this site, it started to kill some of the vegetation. So the water quality answer here would be no. Number 6. Natural surface or subsurface flow patterns are not altered by disturbance, i.e. hoof action, dams, dikes, trails, roads, rills, gullies, or drilling activity. I don't know if we mentioned this earlier, but all of the questions in both the Lentic or the LODIC are set up so that a yes is always a positive answer and a no always means there's some risk or some degradation. So that's why questions like this, it says the flow patterns are not altered, so always remember that saying no means there's some sort of a problem or a risk at the site. In the example photo that's shown on the screen right now, we've got two things going on. You can see some evidence of, it looks like ATV or UTV trailing through there, but then we've also got some hummocking, likely from some sort of livestock or potentially wild horse and burro use. So that water that would either be uniform, shallow across the whole surface, or uniform just under the surface has now had its flow patterns changed because we've had a change in the surface of that site due to physical manipulations. So that would be a no. Same thing here, just a more exaggerated version of it. You can see some really, really bad hummocking here. One of the issues that you start to see with this is you'll get a change of the vegetation type between the bottom and the top of the hummocks because there's such a drastic variation in how much water is available at the bottom versus how dry the top is. The other thing that starts to happen, again, I mentioned there's sometimes it's hard to tell what the potential of the site would have been whether you would have had water ponding at the surface or whether it would have just sort of been uniformly just below the surface. But when you get this sort of uneven water or open water through this site, if you have freeze-thaw cycles, it can start to exaggerate the impact of that hummocking. As it sort of as that water freezes and expands around the base of those hummocks, it can squeeze the soil up even further and take you further away from a functional system. Number 7, structure accommodates safe passage of flows, e.g. no head cut affecting the dam or spillway. Again, this is a very different question than the LODIC one, because some of our sites may actually be created by a man-made structure. And in the event that that's the case, we want to make sure that that man-made structure is being maintained appropriately so that we don't have a catastrophic failure, have the dam breach, have all of the water that's maintaining the wetland habitat go downstream. So in this case, we've got an outlet or an overflow pipe coming out of an earthen dam there, and you can see we've gotten some scour below it and underneath of it, and it's at risk of completely undercutting that structure and allowing a breach to come through.
Questions?
Oh, are you up soon? So any questions on the hydrology portion of the Lentic assessment form?